Hello again. We're going to be solving systems using matrices. This is a pretty easy problem to solve if you did linear combinations / elimination, substitution, or graphing. But I want to show you that you can do this with matrices. Now in order to do it with matrices, you have to first put it in matrix format. So that's what we're going to do. And here we go. We're going to create a coefficient matrix. Coefficient matrix just means the numbers in front of the variables. And those are 2, -3, 1, and 1. That's my coefficient matrix. I'm going to call that A just because I've been calling every matrix that I've been doing A. We're going to create a variable matrix. Our variable matrix is A, oops, why did that say K? A and B. Make sure the variables match up so you don't mess up like I just did right there. So I've got another matrix called A and B. You can use X and Y, you can use any two variables, but whatever. And I'm going to call it a variable matrix X. Now the reason why I choose X is because we always use X as a variable anyways, why not? You can call it Z or C or whatever. Don't use A or B though, because you want to use that for your coefficient and your constant. And that's equal to 3 and 14. 3 and 14 is called a constant matrix because they're constants, there's no variables with it. And we're just going to call that B. So our coefficient matrix is the numbers in front of the variables. Our variable matrix are the variables itself. And our constant matrix is whatever it's equal to. Or matrix, I should say, pardon me. Now what I want to do is I want to basically get X by itself. So I want to get rid of this A right here. Now the only way to do that is by figuring out what its inverse is. Well, that's not too bad, actually. In order to figure out its inverse, though, you have to remember what the formula is for a 2x2 matrix, which is, that means inverse, that little -1, is 1 over AD minus BC, and it's all multiplied by this matrix except you switch terms. The A and the D switch, so it's D and A, and the B and the C are in the same spot except they're negative. I should say opposite, not negative, because if it's already negative, then it's going to switch to its opposite. So I'll go ahead and do that computation right now. Inverse matrix is 1 over AD minus BC, so that's 2 times 1, subtracted by 1 times -3, so that's -3, so it's 2 minus -3, we'll get back to that. And you multiply it by flipping these terms, so it's 1 and 2 and 3 and -1. Bam! We didn't actually finish our matrix yet, though, our inverse matrix. I'm going to go up here so I have some more room. That's 1/5, because 2 minus -3 is 2 plus 3, which is 5, times 1, 3, -1, 2. You know what, let's just do that right now. Well, actually, that's our inverse matrix. So if we take this and we multiply it by our A term, it cancels out, and that's X equals, but whatever I do on one side, I better be doing on the other. Let me say that again. Whatever I do on one side, I better be doing on the other. So it's A inverse of B. So these will cancel, and I'll just be left with this side. It's a little complex to understand at first, but stay with me. So I've got AB equals, and then our inverse matrix, which is 1/5, 1, -1, 3, and 2. You might be asking why I didn't distribute the 1/5. I'll go ahead and I'll tell you why, because I don't want to. If I distribute the 1/5, then I'm going to be working with all 4 fractions. I don't want to do that yet. It's annoying to me. I'm going to multiply by the B matrix, which is 3, 14. And I can multiply it because this is 2 by 2, and this is 2 by 1. Bam! That's going to create a 2 by 1 matrix. So we'll see what happens. 1 times 3 is 3, plus 3 times 14 is, I have no idea, is 42. Got it. Woo! It's a little scared there. No, I wasn't really. It's going to create a 2 by 1 matrix. -1 times 3 is -3, plus 2 times 14 is 28. Bam. And that's all times a 5th. And that's a 5th of 45 and 25. and a fifth of 45 is 9, and a fifth of 25 is 5. So my AB is equal to, when I do all this garbage, 9 and 5, that's an A out of 9. There. So my A is 9 and my B is 5. And those are my answers. And if you don't believe me, go ahead and substitute it in. 18 minus 15 is 3. 9 plus 5 is 14. So it's another way to do it. Now some of you might be saying, I did all that work to figure this out. Yeah, that's essentially what you did. There's really no easy way to sell that. I would personally do this with elimination or substitution, which is why we teach elimination and substitution first. Matrices themselves is a additional form of mathematics. In fact, actually, when I went to school, we didn't have to learn them in the high school curriculum. And the first time I was, well, that's not true, I saw them a little bit. The first time I was really exposed to them was after I finished my calculus sequence. But nowadays, if you're taking math in high school, you're probably going to see matrices long before I did. So you can always think that you'll be a better expert in matrices before I even learn them at your age versus mine. Yeah, so that's, matrices in its introduction form. If you want to learn more about matrices, you can take math after calculus, and you can learn so much about matrices that it'll make your head spin. That's it for now. Have a good day. Goodbye.